So what does the slope look like for this problem here? So we have a cubic function, and at x equals 2 and y equals 8, we want to know the slope of that tangent line. Okay, what is the slope of that line that just runs tangent through that point? Okay, so to do this, I'm going to go set up my rise and run ratio. So I'm going to go the limit as my h goes to 0, okay, of these 2 points. So I need a 2 plus h. Okay, let's put that over here. So that's going to be 2 plus h, where h is negative. Okay, there's my tangent, there's my secant line, and I'm going to bring that point closer and closer to there. And the y coordinate here, when I work that out, is going to be 2 plus h all cubed. Okay, when I plug the 2 plus h into the x cubed, I get 2 plus h all cubed. Okay, so that secant line, I'm going to just bring that green point closer and closer to there, and as I do that, I should be able to get instantaneous slope. Okay, so what does this look like? Okay, so y1 minus y2. So y1 is going to be my 2 plus h cubed. This is going to be 2 plus h cubed minus y2. Well, I know the coordinate is going to be 8. That's all going to be over h, and I'm going to let that h go to 0. Okay, so expanding this out, I want to use a binomial theorem to expand this out. Now, you could FOIL it all out and everything, but if you know the binomial theorem, it just makes it a little bit easier to expand out. So I'm going to get the limit as h goes to 0. This expands out to 8, so 2 cubed plus 2 squared. Oops, I forgot my coefficients. It's going to end up being 3 times 2 squared times h plus coefficient 3. It's going to be 2 to the power of 1 times h squared plus h cubed. Okay, so there's my expansion, and then I have minus 8. This is my y1 minus y2. What's really convenient, and it seems to be happening all the time, is those minus 8s end up canceling out. And there's a reason why, because they're not actually part of the change in y. They're just the y positions, and they disappear when we want the change in y positions. Okay, and this is all over h. So, simplifying this, I'm going to get rid of the plus 8 minus 8, and then I'm going to have all those terms I'm going to simplify here. Okay, so let's see here. So limit as h goes to 0. This is going to be 12h. This is going to be plus 6h squared plus h cubed, and that's all divided by h. Okay, so then I can cancel out some h's there. So I get the limit as h approaches 0 of 12 plus 6 h squared divided by h is h, plus h cubed divided by h is h squared. Okay, so then I can now evaluate this limit. I can plug in h is 0, and I get a slope of 12. Okay, so there's my slope. That line has slope 12. Okay, and again, if I look at that graph, and I look at a slope 12 line, that line is going to be parallel. So it's going to look like it's going to be tangent to that point. Okay, so that's our slope. That we're claiming that that slope of 12 is the correct slope.